13.5 billion years. But the presence of humans, us, what was that number I gave you? 0.04%, wow, of Earth time. We've been around just shortly. And most of that time, human population was very small. Today we're going to talk about the origin of Earth and life. Okay? This course is all about the ways that this planet affects you and you affect it. But we're setting the stage in these first two lectures. Just how did we get here? And one thing about Earth that has always been the truth is that it's always been changing. And clearly you're now part of that change. Okay? So we're filming these lectures. Is it working?
I think so.
And so, you know, I've never filmed my lectures before. But as I chose, oh, where'd it go? Man, woman, somewhere in here. There it is. Whoop. Get out of there. Aha. Here you are. And the syllabus is good. We only got 25 minutes into it. Let's see. And then I don't get it. Oh yeah. Hear that part? This will record. You're amazing. But most of you will need to take notes or type notes. And about the computers being open, I'm fine with that. But do not please go to Facebook or email while you're in my class. Why? Well, it's not respectful for the next person next to you. I mean, if you come in and open up your computer, and I'm sitting next to you, and suddenly you're taking notes, and then all of a sudden you're on Facebook, what am I going to do? I'm going to look at Facebook. I'm going to look at your Facebook page, or whoever you're scrolling, and suddenly I'm not listening to the lecture anymore. And suddenly I'm not getting that information. It just went right by me. And all of a sudden now we've got to have a midterm, and I don't have that information in my mind, and I'm going to get a grade that's lower. I'm going to suck at that exam, and then I don't get a very good grade in the course, and then my GPA sucks, and then I can't get into grad school, and then I go into the Army and I get shot because you opened up Facebook page. That's funny. That's still funny. Okay. Goodbye, Lawford. Okay. Oh my God. Where'd it go? So we're going to do clickers in a moment. If I could figure out my way around all this. That's interesting. And I don't need that anymore. So let's get out the clickers. This may not work. I've been using clickers for many years, but Turning Point, which runs with PowerPoint, has not been upgraded for the Macintosh since 2004. And you can see what it's doing to my font. So I'll try to help you read this. Also, I don't know if my receiver is going to receive all your hits, but we'll get this figured out. How many of you brought your clickers today? Yay! Yeah, look at that. All right, this is 3% of your grade. And what I'm doing here, making this class learner-centered, is showing you real exam questions. Okay? Real exam questions, and you will answer the best of your ability, not for a grade, but for fun. And then we'll see the whole range of scores, how everybody did, true, false, multiple choice. And then we'll show you the correct answer, and you can assess how well you did relative to everybody else. That's if it works. So we'll take a trial here. This is how I know you're in class, and but I won't use it for a grade except for your 3%. I want you all to get that. Looks like response devices are there, automated. I reset the slides, I go to that button. God knows what's going to happen next. My receiver's plugged in. Oh, I love this. Oh, all right. Wow, heating of the inner portions of Earth result from the fusion of hydrogen atoms. Yes?
What channel do we need to...
I don't know, don't change it. Whatever it came with.
It asks you to like enter one in.
Well, we'll figure that out, because I can't remember what channel I'm on. But I'm with you.
Turn it on.
In some ways, this won't count today, you know, because everybody's got their clicker, but most of you do. All right, now here's the next thing I do is I push on that button. Polling open. Go ahead and start shooting. Oh, look, it's working. Yeah, look. 49, 51, you hurry up, 10 seconds, 6, hurry up, click, 65, 4, hurry, beep. Wow, all right. 74% of you said true, and the answer is false. So who really sucks? I thought I talked that well. Hydrogen. Very little hydrogen in Earth, mostly in water, okay? Hydrogen is the fuel of stars and our sun. Okay. What's the fuel of our planet? Radioactivity. All right, you got it. So let's see what the next one is. Planet Earth had very little atmosphere at the time of its formation. Okay, I'm going to open the polls. Start firing away. I won't start the countdown right away. This is working. I can't believe it. It's kind of fun, don't you think? Go ahead, get your iPhones out, take a picture, because I'm not giving these things to you again. Oh, okay. You have to be in class. Okay, now 10. You got 10 seconds. It'll stay there for a while. Plenty of time to take a picture. And then you can fire it around to everybody. Hey, did you get those pictures? Oh, yeah, man, I got them. I'm with you. Okay, and you said true. And the correct answer is true. Wow, very little atmosphere. It was dead. No atmosphere. Where did air come from? Lava? Volcanoes? Yeah, sure. Okay, there we go. All right, this is a real exam question. Are you going to make an A in this course? Look, no one tells us how to grade. All right, you get all above 90%, we're good. Like my good friend would say, we're golden. A rock sample from Saturn, if brought back to Earth, would be much heavier than any common Earth rock. This is a little harder. I may not have stressed this well. Wait, I'm not open yet. Wait. Now it's open. Fire away, and you can change your answer. And we can work together. This is the only time you can talk to each other. I think it's me. I think it's her. I love you. I know, but get through this. And you said, you're still clicking. I forgot the countdown, Margaret. There it goes. There it goes. So 82 of you are getting your minds made up. That's about half of you who got your clickers. There's 160. Half of you have working clickers. And the other half need to get those. And does anybody know what channel works? If you're working, you see a little green light. 41. 41? Okay. Did you... 70% said false. And that's correct. The outer planets are light. They're mostly made out of hydrogen and ammonia and sulfur. Lighter elements. We brought them back to Earth. They would float on water. All right. Let's try another one. That was good. The universe is expanding today. Fire away. Fire. Click. Real exam questions all the time. How much did your clicker cost? Yeah. $32? And they'll take, you get half back at the end of your senior year when you graduate, if you want, but you might be nostalgic about it. And take it with you. This is my clicker. You could show it to your little children someday. You'll have children someday, won't you? All right, 1. And you said true, 97%. I'm getting really good at this, I'm thinking, because that's the correct answer. All right. Is the Earth expanding today? Solar system. All right. Our galaxy? No. Is our galaxy moving, hurling through space? Yes. And what is its relationship to other galaxies? Moving further and further away, causing the red shift. And that's the blank effect. What is it? Oh, yeah. We're gonna ace this course, man, woman. Oh. I'll skip it. Oh no, okay. You got it. I know it felt good. This is learner-centered teaching. And there's your countdown. Hurry up. 8, 7, 6, 5, 4. Who loves you? 3, 2, 1. All right. And you said, excellent. God. 92 of you are here. Fantastic. All right, here's a harder one. The early Earth's atmosphere, once we got an atmosphere from volcanoes, the early Earth's atmosphere is mostly, or was mostly, made of oxygen, carbon, water, carbon dioxide, hydrogen, sulfide, and water, nitrogen and oxygen, and number 4, or helium, just helium. So what would be the best answer? 1, 2, 3, or 4. Now you got to choose. I've opened the polls. Or you're already polling. You're going. All right, hurry up. 3, 2, 1. Let's find out. Multiple choice. And you said, it's shooting the finger at me, Margaret. Okay. A whole lot of you like number 2. And there it is. All right. Fantastic. Absolutely. Breathing out through volcanoes. You breathe a volcano, you're bringing, it's like putting your mouth on an exhaust pipe of a car. Right? Because when you burn gasoline, you're bringing it down to carbon dioxide and water. That's carbonic acid. Okay? All right. I'll do that. Most of the craters on the Earth's moon date back to 4.0 or more billion years. Formed in the last 100 million. Are similar to Swiss cheese, formed from volcanic eruptions. Okay, there you go. Click, click, click. Get in here. Where's your clicker, ma'am? You like hearing it come in late? No. All right. 10, 9. All right. Woo! It's like I'm driving a Model T Ford here. And you said, what do you think? A whole lot of you like number 1, and that's the correct answer. I congratulate you. So that's that. Wonderful. Let's see if I can quit it. Don't save the PowerPoint, but do save session data found. So this is how I could go in if I wanted to and see how you did. I just want to know you're here. Okay? And I'm glad of that. If you miss a few, it doesn't matter. 80%. If you get 80% participation on this, you got a full 3 of the grades. There we go. Save. Now, where am I now? La la la. Then I go to 2012 PowerPoint. Crazy. Or maybe I won't. Teaching is all about technology. There it is. And I've got to have this. Wait till you do your presentations. But before we go there, a bit of show and tell. And talking about what we've already learned. So last time we learned that early Earth rocked by meteorites coming in, meteorites made out of metal and stone, and comets made out of water and carbon dioxide, building up our planet. Our planet going around, because it had mass, it had a force called gravity, pulling in everything. Some were near misses and they went into orbit and became moons. Others crashed really hard and gradually, because gravity is equal in all directions. In the end, we had a nearly perfect sphere for every planet that's out there. Building up. Our average composition was dictated by our distance from the sun, because there was a chemical sequencing. Had the lighter elements further out, heavier elements further in. Thank goodness we had it just right. Our Earth was just far enough out to have a rich mixture of metals like iron and silicon and magnesium and potassium and uranium and thorium, our heat-producing elements, and oxygen. Oh, hey! I felt this warmth go by me. And so that gave us, in any planet that stopped there, I call it the Great Mop-Up, all right? You look up at those bodies today, Brent, and what do you see? No, you look up at a moon.
Oh.
Craters. There you go. How do you do that? Ellie? Emily. Ah, I'm already working on you one by one. I'm going to know all your names. And you never know where I'm at. but never for intimidation. And I'll use Emily and Brett. Y'all know each other?
Yes.
How do you know? Huh? The cribbage? Yeah, really? That's really cool. Now I know I'm not at USC. Do they really?
Pretty good at it.
Oh, God. Okay. Now I've lost everything I was going to say. And so, if we stop there, the great mop-up, all we'd have is craters, and that would be it. But in our planet, we are radioactive. What are the 3 radioactive elements? Uranium, thorium, and in bananas, potassium. That's right. But many others as well. There was an isotope of aluminum that was there. It was very important early. It got all used up. The radioactive elements are using themselves up, but they've got a long ways to go. All right. So there our fuel on the early Earth melted on the inside. The first thing to melt was iron, and it was heavy. A liquid had sunk and made our core. The radioactive elements were left out in the mantle. So I'm repeating myself a bit, but you're getting used to me, right? And you're learning to take notes and getting engaged because I haven't even left the first PowerPoint slide yet, right? All right, you want to be here. Okay, that's what I want you to do. Get engaged and learn, and I'm with you all the way. And so then the radioactive element's still hot. We're left in the mantle. The mantle starts melting, and in the outer half of the Earth melt. We call it magma. Makes lava. Magma, when it's deep inside the Earth, magma. It expands. It expands. It's got negative gravity. When the outer half of the Earth, liquids can compress under high pressure and be denser, and like iron was, it sunk to make the core. Liquids in the outer half, low pressure, expand when they make, and that gives them low density. If you got low density, where do you go? Up like a helium-filled balloon, breaking its way. The first earthquake, so I want to repeat myself, first earthquakes and the volcanoes spewed out on the land, making now crust. So we had a differentiated planet, an iron core, a silicon oxygen, magnesium mantle, and now finally basaltic lava breaking down the Earth's surface and volcanoes spewing gases of carbon dioxide and water. All right? And here it is. First crust of the Earth. All right? Basalt lava. Look at it. And it's full of holes. All right? Full of holes. Bubbling out, making atmosphere. And the Earth has gravity, right? And so where is those gases going to go? But stay. They fill up the Earth. They stay near the Earth's surface, and the clouds then get full. And what do clouds do? But they rain. And so the first rain, but it was acid rain. Carbon dioxide and water makes what? Carbonic acid. And sulfur was coming out. You smell a volcano, sulfur. Sulfur and water makes sulfuric acid. There was also chlorine and fluorine, hydrochloric and hydrofluoric acid. So it rained, and the rain was coming down in acid, and the rocks would hiss and go getting hit by the acid, but gradually that would neutralize the acid waters, and the earth begin to fill. The low point begin to fill with an ocean. All right, but there it is. There's basalt. Look at those holes, frozen in, fossilized. And so Earth, 4.6 billion years ago, quickly awakened and began to erase, just like our moon tried to do. It bled out lava, began to cover up the craters, but it ran out of radioactivity. That's it. You ever driven a car all the way to the end until you're out of gas? Boom, 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 boom. I'm screwed. And so, rather than that, the Earth was not. And so it began to continue to heat, and continued to heat, making lava. It's interesting, though. How do we know all this? Well, the rocks. The rocks are here. The rocks are here. But the odd thing about the Earth, we go to the Earth's moon and get rocks at 4.6, 4.5, 4.0, 4.3, and 4.0 billion years. Every meteorite that comes in, oh, I brought you something, right? Shooting stars. You ever seen a shooting star? I held these up in class last time, didn't I? Yeah, all of these are 4.5, 4.6 billion years. And you know, some of you think big is important. Well, there's a big one. Look at that. Wow. All right, shooting star. Come hold a shooting star. Coming in. All right. But on Earth, we can't find the oldest rock is 4.0 billion years. We can't find any rocks on Earth of 4.1 or 4.2. We can find little minerals that used to make up those rocks, little grains of zircon that are now in sandstones that are younger. We know they were here. They were destroyed. Like Mother Earth chose to kill her firstborn. She ripped out chapter 1 of her book of life. What was she doing? She didn't want us to know. But I'll tell you what, in that first 600 million years, the oldest rock is 4.0. We know it all happened at 4.6. So 600 million years lost. Wow. But we come out of that, we know the oldest fossil is, and the oldest fossil, 3.8 billion, life was here. In those oceans, no life on land. And I'm holding in front of you, can you see that? Look at that. Wow. I'm holding in front of you, don't drink it. This is what the earliest life was. One cell, algae and bacteria, later fungi, and simple things that thrive. These remarkable critters. Now I got this out of a Pasadena, California bird bath. I brushed up, got all that green liquid, scooped it up. You know, and as soon as I did that, about 4 days later, I went and got the bottle, and it was all swelled up, about to explode. And I took it down to our geobiology group, and I said, "Hey, what's going on in your bottle, my bottle?" And they said, "Oh, Lawford, silly, it's photosynthesis." That's really important, photosynthesis, because algae is green. It's one cell, but it's very much plant-like, green plant. And so the earliest life began in the oceans, and it was green. And it would do what plants do today. What do? They breathe in carbon dioxide, and they breathe out oxygen, photosynthesis. And so for the next 2-3 billion years, life stayed in the oceans. And one-celled algae was the most abundant. Bacteria and fungi followed. But they were doing what plants do, breathing in that carbon dioxide. And causing that carbon dioxide eventually to rain down the ocean floor as a lime mud. So today our atmosphere doesn't have all that carbon dioxide. Our Earth's early atmosphere used to be thick like Venus, covering us with greenhouse gases, and it was really hot. This alive planet was hot. But life began. And as that life began, it breathed in carbon dioxide and turned it into stone. Come with me, let's go climb the Swiss Alps. Dolomites and limestones. Sometimes metamorphosed to marble. Beautiful. This building outside, stone and CAS, that white rock all the way down, looks like concrete. Hell no, it's not concrete. It's limestone. Look up closely at it. It's full of tiny little fossils, spicules of sponges and ammonites and little bitty clams breathed in. A fossil hash. A fossil's living and dying on the ocean floor. And so earlier breathed in all that carbon dioxide. And our atmosphere thinned. And what was left was mostly nitrogen, which did not have a mineral to go to. The carbon dioxide went and made calcium carbonate. The mineral's called calcite. Write down calcite. It makes up the rock's limestone. And marble. Wow. The earth breathed it in. The Dolomites of the Alps. Come with me. Why are they called that? So the earth breathed it in. And life stayed in the earth's oceans for the longest time. And then finally began in the last billion years, at 570 million years ago, suddenly life just exploded. In the oceans. Up till then, life didn't have any hard parts. And suddenly life started getting shells and legs and crawling around. This looks like a cockroach that you have on your dormitory floors, but it's a trilobite scurrying around, much like a cockroach, scurrying around, eating and chewing on each other and anything else that was there. These are animals. Suddenly we had life. The first animals were worms. They evolved from bacteria at 800 million years ago. So animals, how do they reproduce? Well, how do you reproduce? Come on, you know. You have sex. So sex, how old is sex on Earth? 800 million years of sex on this planet. All right, so the first worms. But the worms had no hard parts, so it's really hard to find their fossils, but we find them. But 500, that was 800 million, but 570 million years, life just exploded. And we had a garden of Eden of life. Look at all these clams and snails made out of calcium carbonate. Life just exploded, but stayed in the oceans. You can't quite interpret everything I'm saying. Look at all this. Look at that. Huge snails. Ammonites. All right? Look at that. Beautiful. And finally, very late fishes. Around 400 million. Look at that. Now, I've been taking this rock to class many times. I've also gone to many kindergarten classes, first grade classes. One time I dropped it. I was shattered. Like she broke up a date. But anyway, there it is. It still looks pretty good. Oh my God. Yeah. And then, 400 million years ago, those fishes, where their fins are, what did they do? They got legs. No life on land until 400 million years ago. Probably because we didn't have an ozone layer enough. We had finally had enough oxygen, but it was still pretty low. And oxygen gives us an ozone layer. The ozone layer filters out what? UV radiation. Sunburn, cancer, all right? 99% of it. Today, not as well. We'll have a whole class trying to protect you from dying from ultraviolet radiation. But I'm sure nothing could live on the surface of the planet because of all that UV light coming down. We're getting toasted by dark light. But finally, we must have got an ozone layer because the first seeds blew off of lily pads and kelp beds and blew onto land and seeded. And now plants. And then those fishes came out there and they looked out and they saw these plants growing on land. There were flowers. And they said, I got to go eat some of that. And they went. They got legs and they walked out. This is true. Every bit of this. How do I know? How do I know? Oh dear. People hate to teach in this room after me. Look at that. That is a perfect 16-million-year-old fossil. You keep that, Caroline. And there it is. Somebody else come get these too. This is pretty good stuff. 13 million years in age. The rocks are all there. All right? And so the fishes then evolved to become amphibians, and the amphibians evolved to become what? What's next? Reptiles. Reptiles. And so suddenly I'm in the age of dinosaurs, which are really big reptiles. Thundering lizards. And how do we know that? Where? Oh, look at that. Dinosaur bones. All right? 100 million-year-old dinosaur bones. Look at these. And so we got life on land. We got animals running around. Reptiles were thundering lizards, cold-blooded, some warm-blooded. The first birds. Wow. But life on our planet, I said, one constant is change. And as the life became more abundant, at times there would be grand extinctions all over the world, in the oceans, on land, over and over again. There's a small extinction like every 27 million years. And there was some huge ones. Life was stayed in low abundance until that life explosion at 570. All right? And then the number of species, which we group into genuses, and the number of genuses that we group into families, and suddenly the number of families started skyrocketing, and then they would hit a major extinction, first in the Ordovician, and then they would come back. The biggest extinction of them all was at the, write it down, at the Permian-Triassic boundary. It's like Mother Earth looked down on this planet over and over again through time and says, I don't like what I'm creating here. And with a giant eraser would eliminate 50% of all families. You know what that means? To eliminate a family, you've got to kill off all species and all genuses in that family. And to do that to 50% of all families, the number of individuals that you're murdering even in those families that did survive, and we see it happening in one-celled and multi-celled plant and animal alike on land and in the sea, great extinction events. A repeat performance was at the end of the Cretaceous tertiary boundary. We call it the KT boundary. Wasn't as big. Slammed by a huge meteorite. Slam! And they're toast. Coupled with huge outpourings of basalt that changed the chemistry of the atmosphere at the same time. The cold-blooded animals like the dinosaurs perished, never to return to this planet. But of course you know that opened up from the age of reptiles, that opened up the age of mammals. Age of mammals. And suddenly we got kitty cats and dogs and horses and camels. Yeah, and it's all working out. Here, I have a little surprise for you with a decorated box with my name on it. Because the department that I came from gave it to me. Because I've been using this for years. And I found it in 1975 in a dusty old cabinet. And I've been dragging it around to kindergarten classes and this class ever since, except in the 90s. We hired a really nice person named Barbara Grubb. She came from a museum and she saw that I was walking around with a $1 million fossil and eating people with it. Look at that. And she says, I'll offer, can I give you a replica? I said, well, sure. As long as it looks real. Man, woman, does that look real? Look at that. Look at that. You got to see this. So, saber-toothed cat was walking down Wilshire Boulevard in Los Angeles and fell into the La Brea tar pits. And it looks real because the bone, real bone, looks just like the one I had, is porous and tar stains it. But the ivory tusks are impermeable and they don't stain. Okay? This is no longer here either. Extinctions continue. The saber-toothed cat is gone. The dire wolf is gone. A lot of extinctions have continued since that time. It's part of this planet. I mean, even in North America, all the horses disappeared, and all the camels disappeared, and all the elephants disappeared. They just happened to stay alive in Africa. Wow. And some in South America. Wow. All right? Wow. But I hadn't said a word about a human being. And then about 4 million years ago, the Earth entered into an ice age. And the climate began to get cold. The monkeys and apes began to change, knew they had to change where they lived. And they couldn't get there fast enough going on fours. How fast you go when you go on fours? And somehow they got the idea they better stand up and run like hell. And that began the humans. Homo sapiens was very recent, 40,000 years.